Welcome everyone. I am Nora Abdelmageed and I will present JenTab meets SemTab 2021's new challenges. JenTab is a joint effort with Sirko, Schindler, University of Vienna, Germany. Semantic table annotation tasks, as described by SemTab challenge, assign the individual table components to knowledge graph entities, types, or properties. JenTab tries to solve the semantic table annotation tasks. It uses only the publicly available lookup API and Sparkle query endpoint for the target knowledge graph. JenTab follows a create, filter, and select or the CFS pattern and exploits 4 different contexts to implement it. Our default pipeline consists of several modules. This figure shows the abstract view of it. The first component creates as many candidates as possible. The second one consists of a series of filtering functions that exploits the row and the column contexts. The next component is our first attempt to select solutions, followed by creating missing candidates using the row and column contexts as well. The last component represents our last resort of selecting candidates. The rest of the outlook will cover our newly implemented system design and various pipelines, followed by the evolution of JenTab during this year's SemTab challenge. Afterwards, our experiences and results, finally the conclusions and future work. JenTab has a distributed architecture. It consists of a central service named Manager, which is responsible for the workload balance and collecting results, errors, and the audit records. Solver is the core service that performs the preprocessing and executes the actual pipeline. Runner connects the manager and solver bidirectionally. Wikidata and the DBpedia proxies encapsulate the publicly available API and Sparkle endpoint for Wikidata and DBpedia. The pre-computed generic lookup holds mappings for the unique cell values of the entire dataset. Finally, a centralized caching server for the previous 3 services. In the following, I would highlight the new changes of the architecture compared to the last year. We have combined both of solver, clean cells, and the primitive type predictions into one service. Thus, we have reduced the data transfers across services and gained faster execution. We have implemented a new proxy, DBpedia proxy, since SemTab 2021 asks for annotations from DBpedia. We have inherited our previously implemented Wikidata proxy while we have rewritten the queries. Previously, each service maintained its own local cache. Changing that into a centralized server reduced such redundancy. Finally, we have enhanced the generic lookup to become our only means of tackling misspellings. In this year's edition of the challenge, we have encountered various characteristics of the given datasets. Thus, we have implemented multiple pipelines derived from our pipeline full. At first, pipeline essential reduces the pipeline full to its core parts without any further re-executions. Second, pipeline no CPA omits the CPA parts from our default pipeline. Third, pipeline key tables expects a dataset that is grouped by key value pair. Keys represent clean tables or tables without noise. Values represent the noisy tables derived from the clean ones. A clean table is solved by pipeline full, while the noisy tables obtain their solutions from the corresponding clean table solution via broadcasting, like the figure on the right. The next configuration is the pipeline numeric. It's designed for tables that consists of one subject column and a rest of numerical columns. It emphasizes the row context such that it sets the highest priority to those candidates with major support by the rows. The final configuration is pipeline conditional. It combines both of pipeline numeric and pipeline full, such that it tries the pipeline numeric given its precondition, then returns the solution if the coverage is greater than or equal 80%. Otherwise, it runs the pipeline full. In the following, I will discuss the evolution of JenTab during the 3 rounds of SemTab 2021. In the first round, the givens are 2 datasets with CEA and CTA tasks only. The target knowledge graphs are Wikidata and DBpedia. We have implemented DBpedia proxy, and we have used DBpedia Spotlight along with the publicly available lookup API to retrieve candidates. However, we have found many false positives, so we have decided against DBpedia Spotlight. We have tried to solve only CA and CTA without the information from CPA using pipeline no CPA. However, we have found that the use of properties increases the scores, especially the precision. We have created CPA targets on our own based on the given CTA targets and run our full pipeline. Finally, we have analyzed the dataset from Wikidata and encountered massive amount of artificial noise is added to the tables. So we have restructured this dataset into the form expected by pipeline key tables and executed it. In round 2, another 2 datasets are given, hard tables and biotables, from biomedical domain, with a complete set of tasks to be solved from Wikidata. We have tried our pipeline full on both datasets. It worked the best for hard tables, however, we have encountered many timeouts in the case of biotables. Afterwards, we have implemented the pipeline essential and gained our first high scores. However, we have managed to optimize our pipeline full and solve biotables with higher scores. In the last round, the givens are 3 datasets. At first, a new dataset from hard tables with a complete set of tasks with Wikidata target knowledge graph. However, this time we have found the structure of the data is changed. Most of the tables are given by a single subject column and the rest of numerical columns. So we have implemented the pipeline numeric and the pipeline conditional. The second dataset in the last round is BiodevTab from biodiversity domain. It asks for CA and CTA only to be solved from Wikidata. We couldn't relate the given object columns to properties, so we haven't generated the CPA targets. Thus, we have decided to use the pipeline no CPA. We have found interesting characteristics about such dataset. For example, a cell might contain nested entities like researcher and the research institution combined. For this case, we have tried to split the cell and focus only on the first part. Another issue is about the abbreviations of taxon names. For this case, we have implemented a dictionary-based lookup for the abbreviated taxons. The last dataset in the final round is GetTables. It asks for only CTA to be solved from DBpedia and schema.org. It has an interesting table and the target structure. We have found that the targets combine column types and properties. We have splitted the given targets into normal CTA and CPA targets. Then we have created the CA targets to the newly derived CTA. We tried pipeline full over this dataset, but it suffers from timeouts, so we solved it using the pipeline essential. To solve from schema.org, in DBpedia proxy, we have changed the target ontology from dbpedia.org to schema.org. It successfully returned semantic types, but failed to return properties from schema.org. In the following, I would show our experiences and results. The table below shows our analysis of the given datasets, where the highlighted entries are the targets we have generated to complete our experiments. Our generic lookup managed to match more than 99% of the unique values in round 2. Thus, we rely on it as our stand-alone strategy to handle the spelling mistakes. Finally, the table here shows our scores in the first 2 rounds as reported by the AI crowd this year, while JenTab still remains among the top 5 systems of SemTab Challenge for its second time participation. In this presentation, I have explained the updates on JenTab as a participant of SemTab Challenge 2021, giving the details of our newly implemented system design and pipelines. Our code is publicly available under our GitHub repository in the following link. However, we see multiple areas of enhancements of this work. First, the current binary decision to keep or remove a candidate needs to be changed to a scoring system. Second, addressing the lack of targets in specific tasks, like the example of this year get tables would be needed. Finally, the continuous improvement of the JenTab performance, especially for the timeouts from the endpoints. Last but not least, we would like to thank the following people. Thank you all for listening.